those are the notes for lesson 3.1, solving systems by graphing. We're also going to be doing part of lesson 3.2, which is solving by substitution. A system of equations consists of two equations. So for example, we have ax plus by equals c and dx plus ey equals f. So we have two or more equations make up a system of equations. The solution for a system of equations is the point where the two graphs intersect. So if we graph these two lines, the solution will be where they intersect at. To determine whether the coordinates are solutions to the system of equations, we have to plug in the values that they give us. So they give us a coordinate, which is an x and y value. We're going to plug that into our system of equations, both systems, to determine whether it is a solution. So if we get a true statement for both, then it's a solution. If it doesn't work for one of them, then it's not a solution to the system. So let's look at the first example. We have the coordinate 1, 4. Again, we're going to plug in these x and y values to both equations. So let's start with the first equation. We have negative 2 times 1, because again that's our x value, plus 3 times 4, because again that's our y value, equals 10. Negative 2 times 1 is negative 2. 2 times 3 is 12. And we know that negative 2 plus 12 is in fact 10. So since it's true, it works for that equation. Then we need to plug into the second equation. Again, our x value is 1. Y value is 4, so we plug those in. 3 times 4 is 12, so 1 minus 12 equals a negative 5. 1 minus 12 is negative 11. We know that negative 11 does not equal negative 5, so this is not a solution to the system of equations because it does not work for both. Second example, we have the coordinate negative 5, 0. Again, this is our x and y values, so we're going to plug those into both equations. So if we start with the first, we have negative 2 times negative 5 plus 3 times 0. Negative 2 times negative 5 is a positive 10. 3 times 0 is 0. We know that 10 equals 10, so that point works for that equation. We also have to check the second one. So x is negative 5 minus 3 times 0 equals negative 5. 3 times 0 we know is 0. So negative 5 equals negative 5, which we know is true. Since the coordinate works for both equations, then it is a solution to the system. So again, the coordinate has to work for both equations in order for it to be a solution. I want you to think back from chapter 2 when we were graphing linear equations. There are two different forms that we can use to graph linear equations. The first is slope-intercept form. Remember when we were graphing, we first used the slope and the y-intercept to form our line, or to graph our line. The second form we can use to graph is standard form, and we can use our x and y-intercepts. There are three types of solutions to systems of equations. The first is one solution, and this is intersecting lines. So we know that intersecting lines are going to meet at one point, and so that is when we get one solution. The second is infinite solutions, and this is if we have the same line. So you'll notice that the equations are the same. We have the same exact equation, so they're going to share every single point on the line. Therefore, we'll have infinite solutions. The last is no solutions. Again, we know that the solution to a system is where the lines intersect. If there's no solution, then there's no intersecting point, and we know that that means that we have parallel lines. Again, parallel lines will never intersect, therefore there will be no solutions. So we're going to look at these three different types of solutions and different ways to solve systems of equations in the next sections. The first way to solve systems of equations is by graphing. So this first example, we are going to graph both of these lines and determine where the solution is for the system. So first we are going to graph each of these equations. Notice that they're both in standard form. If you remember from chapter 1, we talked about the different ways that we could graph using the different forms. And if you remember, in standard form, one way that we can graph is using the x and y intercepts. Now, it would always work to change this to slope-intercept form, but we could also find the x and y intercepts as well. So we're going to start with our first equation here. We have 2x minus 2y equals negative 8. So again, we're going to find the x and y intercepts, and we're going to use that to graph. To find our x-intercept, remember we make y equals 0. So we get 2x equals negative 8. We divide by 2 to solve, and x equals negative 4. To find our y-intercept, we make x equals 0. So that gives us negative 2y equals negative 8. Again, divide by negative 2, and y equals a positive 4. So on the graph, we're first going to go to our x-axis. We're going to go to the left 4 and plot our point there, because again, that's our x-intercept. Our y-intercept is at positive 4, so we're going to go up to 4 and plot our point there, and then we're going to connect our dots. Now it's very important to be very accurate when you are solving by graphing, because if you're not accurate, then you're not going to be able to see your solution. Then we need to do the same thing with our second equation. Again, we're going to use our x and y intercepts because we're in standard form. So first, to find our x-intercept, we're going to make y equals 0. So we have 2x equals 4. Divide by 2 to solve, and x equals 2. Then to find our y-intercept, we make x equals 0. So we have 2y equals 4. Again, divide by 2, and y equals 2. So again, on our x-axis, we're going to plot 2. Again, that's our x-intercept. And a positive 2 is our y-axis. And again, we're going to connect these to form our line. Now, the solution, again, is where these lines intersect. So if we look at our graph, you see that our lines intersect here at this black point. And we know that that's the coordinate negative 1, positive 3. So our solution is negative 1, 3. And again, if we plug this into both equations, we should get true statements, and that tells us that it is for sure the solution. Our second example, again, we're solving by graphing. We have 2x plus 4y equals 12, and 2y equals negative x plus 6. Now in this case, if we look at our first equation, again, it's in standard form. So this time we're going to change it to slope-intercept form to graph. So again, to change to slope-intercept form, so we're looking at our first equation here, we need to get y all by itself. So the first thing we need to do is subtract 2x from both sides. And that gives us 4y equals negative 2x plus 12. Then to get y all by itself, we are going to divide by 4. If you remember, we divide everything by 4. So y equals negative 2 divided by 4 is negative 1/2. And 12 divided by 4 is 3. So again, let's graph this. We know that our y-intercept is a positive 3, so we're going to go up 3. And then we're going to use our slope to find our second point. So we're going to go down 1 to the right 2. And again, we can get multiple points on the graph and then connect them to form our line. Then we need to do the same thing with our second equation. Again, we're putting this in slope-intercept form. Now notice we have 2y equals negative x plus 6, so we're almost in slope-intercept form. We just need to divide by 2 to completely finish. So y equals, think of this as negative 1x, so negative 1 over 2, so that would be negative 1/2 x, plus 6 divided by 2 is 3. Notice that we have the same exact equation. If we have the same equation, remember that means that our solution is infinite solution because we have the same line. So this is telling us that every single point on the line is shared with both equations. Our last example of solving by graphing, we have y equals x plus 5 and 2x minus 2y equals 8. Notice the first equation is already in slope-intercept form, so we can just go ahead and graph that. So we know that our y-intercept is 5, so we're going to go up to 5 on the graph, on the y-axis. We know that our slope is 1 because there's no number in front of the x, so we're going to go up 1 over 1. Now notice that this is going off our graph, so we're going to have to go down 1 and to the left 1. And again, it's helpful to put multiple points on your graph. It just helps to see where the solution is at. Then let's look at our second equation. Again, let's change this to slope-intercept form. So we want to get y all by itself, so we're going to subtract 2x. That gives us negative 2y is equal to negative 2x plus 8. Divide by negative 2. Again, we're dividing everything by negative 2. So y equals negative 2 divided by negative 2 is a positive x. and 8 divided by negative 2 is a negative 4. So if we go to our graph, again the y-intercept is negative 4, so we're going to go down 4. Again, our slope is 1, so we're going to go up 1 over 1, and then draw your line. Now notice that these are parallel lines, so that means that they are never going to intersect, so there are no solutions. Now a way to check to make sure that we have the correct answer, go back to your equations. What do you notice about the slope? You should notice that the slopes are the same. Again, if you remember from chapter 2, parallel lines have the same slope. So because they have the same slope, we know that they're going to be parallel lines, and we know that they're never going to intersect, so therefore there are no solutions for this system. The next part of our notes are actually the first part of lesson 3.2, which is using substitution to solve linear systems. The steps for using substitution is to solve one equation for x or y. It does not matter where you start, but you just need to make sure that you have one variable by itself. So for instance, y equals 2x plus 5. So we want a variable by itself on one side of the equation. The second step is to take the result in step 1 and to substitute. That's where this process gets its name from. So we're going to substitute into the other equation. So if we solve one equation for x or y, we're going to substitute that into the other equation. The third step is to solve for the variable. So whatever variable we have, we should only have one variable after we substitute in, and we're going to solve for that variable. And the last is to take our answer from step 3 to find the other variable, again by substituting in the equation. So again, we're just substituting back and forth between the two equations. So if we look at example 1, again, we first need to solve one equation for either x or y. Now, if we look at our equations, it does not matter where we start, but a lot of the times one equation is going to be easier to solve than the other. If we look at these two equations, notice that we have one variable all by itself without a coefficient, and that's your y right here. So that's going to tell us that it's going to be easier and faster to solve for y for our first equation than to deal with our second equation. So if we solve for y for our first equation, we're going to add 3x to both sides, and that will get us y equals 3x minus 13. So then we're going to take this value for y, which is 3x minus 13, and we're going to plug that in for y in our second equation. So we have 2x plus 2 times 3x minus 13 equals a negative 10. So again, we're just taking what y equals in our first equation that we solved for and substituting that in for the y in our second equation. So then we just solve for x. So first we need to simplify by distributing. So we have 2x plus 6x minus 26 equals a negative 10. We can combine our x's, so 6x plus 2x is 8x. Then we can add 26 to both sides, so that gets us 8x equals 16. We divide by 8, we get x equals 2. So then we plugged into our second equation to solve for x. So now we're going to go back to our first equation to find out what our y is. Again, the solution for systems is where our graphs or where our lines are intersecting. So that's going to be a coordinate. So we always need an x and a y value. So we're going to take our x value of 2 and we're going to plug that back into our original equation. Now we can either use the original or the rearranged equation. Notice that the rearranged equation might be a little bit faster, or is a little bit faster, because then we don't have to resolve. So we're going to plug in 2 for x. So that gives us y equals 3 times 2 minus 13. Y equals 6 minus 13. So our y value is negative 7. So our solution, again, is a coordinate. Our x value is 2. Our y value is negative 7. Again, we can go back and check by plugging these values back in to make sure that they both work. Our second example, again, we're solving by substitution. Notice that if we look at both of our equations, one is already solved for y. So we're just going to take this value, the x plus 5, and we're just going to plug that in for y in our second equation. So we have 2x minus 2 times x plus 5 equals 8. Again, we're going to distribute first. So we have 2x minus 2x minus 10 equals 8. 2x minus 2x is 0. So we have negative 10 equals 8. Notice that our variables disappear, and we have an answer that is not correct. Negative 10 does not equal 8. So in this case, if all of our variables disappear and we're left with an untrue statement, we know that that means that we are going to have no solutions. So if you remember, if we have no solutions, that means that our lines are going to be parallel. In our last example, again, we're solving by substitution. Notice that we have 3 variables this time. So we have to solve for x, y, and z using substitution. So we're going to start with the simplest equation and solve for a variable that we can. So if you notice our last equation, we have 2x equals 18. We only have one variable, so we can go ahead and solve for that. So our first step is to divide by 2. So that gives us x equals 9. So that's the first part of our solution. Now we can take this and we can plug it back into one of our other equations. It does not matter which one you plug into. I'm going to use the second one just because there's only a negative in front of the x. There's no number, so that we have to multiply. So again, I'm going to use this second equation, plug in my x values to get more simplified equation. Again, I'm going to get my y's and my z's all on one side, so I want to get rid of the 9. So I'm going to add 9 to both sides. So I have 2y minus 2z equals 14. Now if you remember from above, we need to get a variable all by itself. So we either need to solve for y or for z. In this case, the y is a positive number, so I'm going to solve for that. Again, you could solve for z, that would work as well. So we're going to add z to both sides. So 2y equals 2z plus 14. And then I need to divide everything by 2 to get y all by itself. So we get y equals z plus 7. So now from this, we can plug into our first equation. Again, we know that y is equal to z plus 7. So we're going to plug our x value and our y value into our first equation so that we can solve for z. So again, we're going to use our first equation to plug into. So we have negative 3. We're going to times that by 9, which is our x value that we already solved for, plus 2 times, and then we're going to substitute our y value, which is z plus 7. And then the rest of our equation is minus 3z equals a negative 13. So again, notice we only have z's in our equation, so we're going to solve for z. Now the first thing we can do is simplify, so we have negative 3 times 9, which is negative 27. To get rid of the parentheses, we have to distribute, so this is plus 2z plus 14 minus 3z equals a negative 13. We can combine our z's and then combine our constants, so 2z minus 3z is a negative z. Negative 27 plus 14 is a negative 13. That equals negative 13. So again, to solve for z, we're going to add 13 to both sides. So negative z equals 0. Divide by a negative 1, or multiply by a negative 1, it's going to get you the same answer. Z equals 0. So now we have our x value of 9. We have a z value of 0. We just need to figure out what y equals. So we're going to go back to this equation here. We're going to plug in our z value, and that will give us y. If we plug in 0 for z, we know that y equals 7. So our final solution is 9, which is our x value, y is 7, and z is 0. And again, we always write them in alphabetical order. So 9, 7, and 0 is your solution.